mathematical tool used in proving stuff. It's a way to prove something is true for all the natural numbers. Or if you massage it right, another set, but basically it's for all natural numbers. Now the idea is, if I know that 1 or some number, if I know some number is in a set and the next number is always in there. So in other words, if n is in S, then n plus 1 is in S. So these two brought together, used together, 1 is in there, and whenever a number is in there, the next one must be in there, tells me that S has to equal the natural numbers. Because you have 1 is an element of S, which means by this thing, 2 is an element of S, which means by this thing, 3 is an element of S, which keep going. So this is a very strong tool we use. So to prove something by induction, we first prove it's true for a base case. You have to prove it's true for something because you need that, well, if n is in there, the next one is in there. But if n isn't in there, you're screwed. So you need to make sure that S is not empty for this to be the case. And then you assume true for n, because you need to say if S is in, n is in, let's try this again. If n is in S, so you're saying assume it's true for n, and then prove n plus 1 is in S, where S is the set of the numbers that make it true. So let me do an example. Prove 1 plus 2 plus yada 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 plus n. If you add up the first n integers, you will get n times n plus 1 over 2. This is a formula we kind of thought about in class at some point. But now I'm going to prove it. Prove. I'm going to say, this is kind of my general notation, if n equals 1, 1 plus 2, yada yada yada, plus n, well, if n is 1, this is really just 1. And n times n plus 1 over 2 is equal to 1 times 2 over 2, which is 1. These are equal. Therefore, how do I say this? Since 1 plus n is equal to n times n plus 1 over 2 for n equal 1, we know this is true for n. This is really redundant. This is okay. Next part. I want to prove that if it's true for n, it's true for the next one. So it's going to look like I'm assuming what I'm trying to prove, but I'm trying to do it for specific n. So let me kind of emphasize that. Suppose there exists an n such that 1 plus 2 plus n is equal to n times n plus 1 over 2. So we know it's true for this one n. What about the next one? So notes, I need to show for n plus 1, which means, I'm going to screw that, I need more space. So what I need to show is 1 plus 2 plus yada 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 n plus n plus 1, so go that one extra step, has to equal n plus 1 times n plus 1 plus 1 over 2, which normal people write as n plus 1 times n plus 2 over 2. This is what we need to show. Let me show you what it says. Okay, so we're going to start on the left side because this is how I like to do it. 1 plus 2 plus 3, I can say 1 plus 2 plus ... plus n plus 1 is equal to, well, I know that 1 plus 2 plus ... plus n is equal to n times n plus 1 over 2. So I'm going to substitute that for the formula. And then I still have this n plus 1 over here. Now I need to figure out how to algebraically manipulate that so it looks like that. So let's see what I'm going to do. I'm going to factor out an n plus 1 from both sides. I mean, from both terms. And I'm left with n over 2 plus 1. Well, n over 2 plus 1, well, 1 is the same thing as 2 over 2, so this is n plus 2 over 2, which is what we wanted. Therefore, for all natural numbers, 1 plus 2 to n gives me the formula n times n plus 1 over 2. Let me try another one. Example, I want to show that 3 to the n is greater than or equal to 1 plus 2 to the n. For all n in the natural numbers. So proof. If n equals 1, 3 to the 1 is equal to 3. 1 plus 2 to the 1 equals 3. Since 3 is greater than or equal to 3, this is true for n equals 1. Second, suppose there exists an n such that 3 to the n is greater than or equal to 1 plus 2 to the n. Need to show that 3 to the n plus 1 is greater than or equal to 1 plus 2 to the n plus 1. Now this is going to be a good example of keeping in mind where you're headed. So I'm going to pull some tricks that you're not going to like. But it's because I know where we're going. So, remind myself, need to show 3 to the n plus 1 greater than or equal to 1 plus 2 to the n. That's greater than, right? Don't do the wrong thing. Okay, so let's start on the left. I have 3 to the n plus 1. Oh, what's that equal to? Well, that's equal to 3 to the n times 3. Well, I know 3 to the n. I know something about 3 to the n. I know that it is greater than or equal to 1 plus 2 to the n. And I'm going to run out of space. So I need to get this one. What can I do? Let's pull the 3 through. This is equal to 3 times, 3 plus 3 times 2 to the n. And that's where I'm going. I want this to be bigger than that. Well, but think about this. Is 3 bigger than 1? Well, yes, it is. So this is greater than or equal to 1 plus 3 times 2 to the n. Now, I have, oh, that's supposed to be plus 1. My bad. Too bad you couldn't tell me that was wrong and do a roll. Now here I have 3. And 3 times 2 to the n, I need 2 to the n plus 1. Well, 3 is bigger than 2. So I'm going to replace the 3 with a 2. So this expression is 1 plus 2 times 2 to the n, which, oh boy, that's equal to 1 plus 2 to the n plus 1. So I've proven that 3 to the n plus 1 is greater than or equal to 1 plus 2 to the n plus 1 when the expression is true for n. So therefore I know for all n, 3 to the n is greater than or equal to 1 plus 2 to the n. Now, if you don't like this, let me show you another way we could do this. Ooh, I'm getting on 10 is. Let's see, alternate. Still do the n is equal to 1 the same way. But, so we're going to suppose 3 to the n is greater than or equal to 1 plus 2 to the n. Now I can take this expression, multiply both sides by positive 3, and get the same truthiness. So I have 3 to the n plus 1 is greater than or equal to 3 times 1 plus 2 to the n. I'm going to do the same thing I did before. I'm going to rewrite that as 3 plus 3 times 2 to the n, which is greater than or equal to 3 is bigger than 1. Three is bigger than 2. So now I have 3 to the n plus 1 is greater than or equal to 1 plus 2 to the n plus 1. By the way, I can get away with doing this because these are all either equal or greater than. If somewhere in here there is a less than, I'm screwed. Then I have to stop. I messed up. Okay. We'll practice many more induction problems, but those are a couple for you to look at before class. Now I need to find where my cursor is. There we go.